Hi, today we are going to talk about convolutional neural networks and use them to classify images if they have potholes or not. So the key idea behind this project was to get acquainted with the decision making during training and hyperparameter tuning to get a model good enough for classification. And starting with the motivation behind this binary classification problem, potholes are kind of a road damage which could be very dangerous for autonomous vehicles as they can, potentially lead to severe accidents. And therefore, their detection is very important to take the evasive measures. So the original dataset consisted of around 11,000 high-resolution images with a high imbalance. Out of this, 1,000 images each for test and validation set was selected randomly, and out of the 1,000 images, 200 were positive and 800 were negative images. Data augmentation included random cropping, horizontal flipping, etc., for marginally increasing the information which was fed to the model to learn. Two popular CNN models, that is ResNet 18 and GoogleNet, were tuned to compare the performance. ResNet 18 essentially has residual networks, and the GoogleNet architecture basically employs the inception architecture. And both of these networks has 1,000 neurons in the last layer, and this was changed to 2 neurons for the binary classification problem. So around 65 experiments were run by varying a lot of parameters, hyperparameters, by varying the optimization function, the beta 1, beta 2, learning rate, batch size, and momentum value. And so these are the results that we got for the best performing models of ResNet and GoogleNet. So the left column is for GoogleNet and the right column is for the ResNet. And the first row gives the precision, second recall, and third the F1 score. So from this bar graph, as we can see, GoogleNet performed better than ResNet by around 1%. And from this table, you can see it performed better than ResNet across all the metrics. And there were very two interesting observations. So first of all, we used the scheduler step, which decayed the learning rate after certain number of steps, and those certain number of steps, if we varied that, it considerably changed the performance, even by 1%, which was unexpected. And second was, so these are the two confusion matrices. The vertical is the predicted labels and the horizontal is the true labels, with this particular column being the positive and this particular row being the positive examples. So as you can see here, 184 positive examples were correctly classified and 797 negative examples were correctly classified from the 800 negative examples. After introducing the weights to the cross entropy loss function, we got this matrix. And what we observed was, though the number of misclassified positive examples went down from 16 to 11, the number of misclassified negative examples actually rose from 3 to 10, which overall decreased the precision. So in all, GoogleNet gave better results across all the metrics. So in the future work, we can experiment with more common architectures or even build from scratch. Thank you.